All right, so let's back up a little bit, right? Discovery identifies CoQ10b, the gene, right, as one of 3 transcripts. So after I looked at like 12,900 different genes, which correlates with age, right? So I've been doing a lot of research with correlating with gene expression and age, meaning microarray data, meaning the transcriptome, and correlation with age, right? So this, I believe, positions this as a biomarker that is an important aspect in aging, right? So I'm testing the hypothesis, which I hear you see here in the graphic is what I'm talking about, right? That the NDUF6 or NDUFS6 and the CoQ10b, the gene, they're both genes, right? That axis constitutes a critical bioenergetic bottleneck, and you see it on the graphic. So the upregulation of CoQ10b is a compensation response or a compensatory response. And so it compensates when you have mitochondrial stress. That's what I'm trying. Now, and that inadvertently, or maybe by design, triggers an inflammatory cascade, which then activates a senescence in an MSC, or an inflammatory phenotype, right? And we call it SAC, right? And so if you were to understand that axis, and you know that the upregulation of CoQ10b is kind of the culprit, then you could target or uncouple that metabolic stress in that cascade and then reduce, reduce the inflammation phenotype. Now, so you have that, and you see that in the graphic here, right? So we have our complex 1, or NDF high, NDUFS6 or NDUF6, and we have our CoQ10 synthesis, which is here in the blue teal mitochondria, right? So it's a healthy young mitochondria. That's really what you got to remember. And because the electron transport chain is efficient, then you have a healthy regeneration function, healthy cells, healthy MSCs with healthy mitochondria. Now, when you start aging, you get this guy here, which looks, it's the color of angry. And that is a complex that is, it has a low NDUFS6, and so it has a defect, mitochondrial defect, and it has CoQ10 deficiency, whether it's like too high or low or whatever. Now, then that bottlenecks the electron transport chain, and it gives you this high reactive oxygen species, which is part of stress. And then you start moving down this senescence and an inflammaging pathway. And that's the essence of it. That's a lot. And